Hello students, this is Professor Chalai, and in this video we're going to look at the formula mass and the mole concept. By the end of this video, you should be able to calculate the formula mass and the molar mass of various compounds, and also describe what the mole is. Let's get started. As always, you can follow along with our chapter worksheets, and this will be the beginning of chapter 3. So far we've looked at atomic masses, where for example, let's look at carbon. Carbon, we know, has an atomic mass of 12.01 about atomic mass units, right? The formula mass is simply the sum of all of the atomic masses of all the atoms in a compound. So let's write that. So the formula mass is the sum of all of the atomic masses of a compound. Let's look at an example. So let's say we have a compound like sugar, C6H12O6, right? Glucose. What is the formula mass of this compound? Well, it'll be 6 times the atomic mass of carbon. So that's 12.01 atomic mass units. It'll be plus 12 times the atomic mass of hydrogen, that's 1.01 to 2 decimal places, plus the atomic mass of oxygen, that will be 6 times 16.00 atomic mass units. So the formula mass for glucose is 180.18 atomic mass units. Note that because we're summing all of the atomic masses, the units are also going to be the same as the units for atomic mass. And so units for the formula mass will be in atomic mass units. But what is an atomic mass unit anyway? And is that even useful for us? An atomic mass unit, remember, one atomic mass unit is about the mass of a proton, which is a very, very small amount of mass. And usually when we're dealing with molecules, we're dealing with a large number of molecules, very large number of molecules. And so dealing with units of atomic mass units are not very useful. And that's where the idea of a mole comes in. We're never going to be dealing with 1 atom or 2 atoms or just a dozen atoms. We're dealing with an absurdly large amount of atoms. For example, in 12 grams of carbon, they're going to be about 6.022 by 10 to the 23 molecules of carbon atoms, right? That's a crazy large number. And so the same way we we have names for small groups of numbers. For example, 2 things we call a pair, 12 things we might call a dozen, and so on. We're going to give a name to this specially large number of things, and we're going to call that a mole. So that's the number of moles, and we could figure out the number of moles from Avogadro's number. Basically, 1 mole of things, atoms, molecules, grains of sand, doesn't matter, is exactly equal to 6.02214 and so on by 10 to the 23rd particles. That's the definition of a mole. Particles here could mean atoms. It could mean molecules. It could mean any collection of things. So the definition of a mole would be an amount of substance equal to 6.022 and so on by 10 to the 23rd discrete entities. Whether those entities are atoms or molecules or so on, doesn't really matter. So instead of talking about 1 molecule, for example, that'll have a very tiny mass in units of atomic mass units, we can talk about a very large number of those molecules that'll have a mass that's closer to what you're accustomed to in the lab. And so that gives us what we call a molar mass. Now, by molar mass and formula mass are actually identical in number, just the units are the same thing, because while the formula mass is just talking about the mass of one molecule based on the formula, the molar mass is talking about 1 mole or this amount of those molecules. And so the mass for that would be in grams. So the formal definition for a molar mass is the mass in grams of 1 mole of substance. And so the units will be in grams per mole, right? It's however many grams 1 mole of substance weighs. So with that, let's think about number 1 for a second. Which one do you think weighs more? 1 mole of carbon or 1 mole of oxygen atoms? Carbon atoms or oxygen atoms? Pause the video and see if you can figure that out for yourself. And when you're done, you can unpause and let's see what we get. So 1 mole of carbon and 1 mole of oxygen atoms means that we have the same number. So let's say we have some collection of carbon atoms and some collection of oxygen atoms. They're both 1 mole, which means we have the same number of carbon atoms and the same number of oxygen atoms. One carbon atom has a mass of about 12.01 atomic mass units. So 1 mole of carbon atoms will have a mass of 12.01 grams. Does that make sense? All right, let's look at oxygen. So 1 mole, one oxygen atom has an atomic mass of 16.00 atomic mass units, which means that 1 mole of oxygen will have a mass of 16.00 grams, because the molar mass would be 16.00 grams per mole. So 1 mole of oxygen atom weighs 16 grams, whereas 1 mole of carbon atom only weighs 10 grams. So in this case, 1 mole of oxygen atoms actually weighs more. Let's try number 2. Which one do you think has more atoms in it? 1 gram of gold or 1 gram of silver? Pause the video here, and when you think you have the answer, on pause, and then we'll go over this answer again. So 1 atom of gold has an atomic mass of about 196.97 atomic mass units, whereas 1 silver atom has an atomic mass of 107.87 atomic mass units. However, their total masses are the same, right? We have 1 gram of silver versus 1 gram of gold. So because silver is lighter, has a lower atomic mass, then you would need more silver atoms to add up to 1 gram. Compare that to gold. Each gold atom is heavier, so you would need less or fewer gold atoms to add up to 1 gram of gold. Think of these as like maybe elephants. That's my elephant. Compared to, I don't know, a human. Humans are lighter than elephants. So if we were looking to add up elephants such that they weigh 10 tons versus we're adding up humans, right? Such that they weigh 10 tons, right? The same total mass. We'll end up having more humans on the scale than elephants on the scale. All right, so just to summarize what we've learned about, the formula mass is simply adding up all of the atoms in a compound. We did an example with glucose. However, formula mass and atomic mass units isn't really relevant for doing chemistry in the lab, because that's talking about 1 atom or 1 molecule. So then we defined the mole, which is just a word for a very large number of things. And that large number is exactly given by Avogadro's number. Note that in Avogadro's number, 1 mole is equal to this many particles, where particles could be anything from atoms to molecules to really any collection of things. And so using the mole, then we can have what we call the molar mass, which has the same units, the same number as the formula mass, just now expressed in grams per mole, where gram is a unit of measurement that we use in lab more frequently, and it expresses the mass of 1 mole, which is a very large number of particles. All right, I'll see you in the next video where we're going to use this mole concept in calculations. See you then. Bye.